In this pencast, we're going to be learning how to solve word problems involving applications of exponential functions. So this problem says, the population of a certain country can be modeled by the expression P of t equals 50 e to the 0.02 t, where P is the population in millions, t is the number of years since 1900. Find when the population is 100 million, 200 million, and 400 million. And what do you notice about these time periods? Alright, so let's start by trying to find the how many years it took the population to reach 100 million. So, what we want to find is t. So, what we have is 100 million is equal to 50 e to the 0.02 t, and we're trying to solve for t. So the first step is to divide both sides by 50. When you do that, you get 2 million is equal to e to 0.02 t. Now, since we want to solve for t, and it's an exponent, we need to get it back into the regular part of the expression. And to do that, what we're going to do is do the opposite of e, which would be take the natural log of both sides. So we're going to take the natural log of 2 million, set that equal to the natural log of e to the 0.02 t. So if you go ahead and put that in your calculator, the natural log of 2 million is 14.51, and that's equal to 0.02 t, since the natural log cancels out the e. So now what we need to do is divide both sides by 0.02, and when we do that, we get 725.43 equals t. So that means that it takes 725 years to get to 100 million. Alright, so now let's continue and start with 200 million. So we're going to do the exact same procedure. So we have 200 million equals 50 e to the 0.02 t. So divide both sides by 50, and we end up with 4 million is equal to e to the 0.02 t. So then we take the natural log of 4 million, set that equal to the natural log of e to the 0.02 t. And when we put that in our calculator, we get 15.20 equals 0.02 t. Alright, if we divide both sides by 0.02, we get 760.09 equals t. So that means that it takes 760 years to get to 200 million people. So the last one we need to do is 400 million. Again, it's the exact same procedure, so I'm just going to write out the last step. Okay, so what you should end up with is taking the natural log of 8 million, setting that equal to the natural log of e to the 0.02 t. And once you solve that, you should get t is equal to 794.75. Alright, so the last question asks, what do you notice about these time periods? Alright, so it takes us 725 years to get to 100 million people. And then it only takes us about 35 more years to get to 200 million people at 760 years. And then after that, it only takes us about 35 more years to get to 400 million people, or which would be at 794 years. So the best way to actually represent this visually is going to be to graph it. So let's go ahead and sketch a graph here. Okay, so on the x-axis, we're going to have time. In years. And in the y-axis, we're going to have population in millions. Okay, so let's just start at 600 years. And let's say this is 700 years. And this is 800 years. Alright, so on the population side, we've got 100 million, 200 million, 300 million, and 400 million people. Alright, so let's plot the points we have here. So we have at 725, about 725 years, we're at about 100 million people. So right here. And then at 760 years, so this would be 725, this would be 750, so a little after that, we're at 200 million people. And then at 794, which is almost at 800, we are at 400 million people. Alright, so if we try to connect those dots, we're going to see that we have a curve right here. Okay. So that's what our graph looks like. We can continue that onward. Alright, so if we look at these numbers again, we can see that 794.75 minus 760.09 is 34.66 years. And we can see that 760.09 minus 725.43 is also equal to 34.66 years. So basically what this is telling us is the population doubles every 34.66 years. So every 34.66 years, which is about every 35 years. And that means that what we have is exponential growth, which we can also see by the shape of this graph. The shape of this graph indicates exponential growth. So if this trend continued, we know that after 34.66 more years, we would have 800 million people. So that's what we can tell from working this problem out.